Hey yo, what's up? For this video, right, we are looking at limiting and excess reagents and how to calculate or determine the limiting and excess reagents in a question or from a calculation. So let's define what limiting reagent or reactant is. So the limiting reactant limits the amount of products that can be made in a chemical reaction, and the excess reactant or reagent is the reactant that remains at the end of a reaction. So the limiting reactant always determines the speed of the reaction or how long it will last. So I have a chemical equation here. Why did I bring it? To tell you that the coefficients in a balanced chemical equations tell us the molar ratio of the reactants and product. So before you delve into calculating what the limiting reactant or what the excess reactant is, first you need to balance the equation to find the molar ratios or the coefficients in front of the formulas. So the molar ratio, for example, for this equation would be 2 to 1 to 2. So 2 magnesium to 1 oxygen molecule to 2 magnesium oxide. So we have an example here. I was supposed to find which one is the limiting reactant and which one is the excess reactant. So iron trioxide reacts with carbon to produce iron and carbon dioxide according to the following equation. 2 iron oxide plus 3 carbon gives us 4 iron plus 3 carbon dioxide. So our mass for iron oxide is 500 gram, and for carbon as well is 500 grams. So let's find the mole for both. So the mole for iron oxide will be mass over molar mass as usual. This is 500 gram divided by what's the molar mass for iron oxide. You can calculate it by yourselves, but here I have it as 159.70. So you get 3.13 mole, so 2 decimal points. And for carbon, we have mass over molar mass 500 divided by 12.01, which gives you 41.6 mole. So I know you might be tempted to say 41.6 is greater than 3.13, so 41.6 is the excellent reagent, but we can't be sure. So before we are sure, we have to remember to divide the mole by the coefficient in front of the formulas here before you are sure. So for iron oxide, the coefficient is 2, so you divide the mole, which is 3.13 by 2. And for carbon, which is 41.6, so you divide it by 3. So for the first one, you will get 1.57, and the next one you get 13.9. So yeah, for this one it's obvious, but for some equations, if you don't divide it by the coefficient, confuse the limiting reactant with the excess reactant. So the one with the smallest mole is our limiting reactant, and the one with the highest is our excess reactant. So let me just write it. Is equals to Fe2O3, and excess reactant will be carbon.